Okay, on one side we are having the solids. On the other side we are having water and calorimeter.
Yeah.
Okay, I'll make the columns over here like this. The first thing is the mass. I'll take the mass of solid as M1, mass of water as M2, and mass of calorimeter as
M3.
M3. Okay, then I'm going to consider the second column, which is going to be the specific heat capacity. I'll take for the solid as C1. For water I will take it as C2, and for calorimeter I will take it as C3. Now in temperature column I'm going to make three parts over here. One is the initial temperature, then we are going to have the final temperature. Remember, all the three final temperatures will be same,
Yeah.
correct? Because after you mix them, the final temperature is going to become one and the same for all three of them.
Yeah.
And then we are going to have the difference. Okay,
Yeah.
that is delta T1 or simply T1, delta T2 or T2, and delta T3 or T3. So the principle that we are using over here is heat lost by hot body, that is equal to heat gained by cold body. Of course, here we are ignoring the heat that is lost to the surrounding. That's why we are keeping that insulation box, so that less of the heat is lost to the surroundings. Now, which is the hot body over here?
The solid.
The solid. The cold body over here is water and
Calorimeter.
calorimeter. Correct?
Yeah.
So the heat lost by hot body, this will be given by the formula Q is equal to MC delta T. So that is going to be M1 C1 delta T1.
Yeah.
Now for water, this is going to be M2 C2
Delta T2.
delta T2 plus M3 C3 delta T3.
Yeah.
Okay. Mass of solid we can find. Mass of water also is known. Mass of calorimeter is known. We don't know the specific heat capacity of the solid. Okay. Specific heat capacity of water is given, that is 4.2 joules per gram degrees Celsius. This calorimeter is made up of copper, so its specific heat capacity will be 0.39 or 0.4 joules per gram degrees Celsius.
Yeah.
Initial temperature will be measured of solid and also separately initial temperature of water and calorimeter.
Yeah.
Final temperature after mixing the substances, that is after putting the solid inside the water and calorimeter. Okay, we will get the final temperature, and then we'll take the positive difference of these two of them in all three cases.
Yeah.
Okay, so all the values are known, only one value is unknown. So by using this method, we will be able to determine the specific heat capacity of a
Solid.
substance, and that is a solid.
Yeah.
Okay, so on the basis of this, we are going to have numerical. Now apart from this, okay, we are also going to have other numericals which are there. Okay.
Yeah.
That is, suppose here we are having hot water and we are having cold water.
Yeah.
Okay, this is our normal experience when we are taking our bath. If the water is too hot, what do? We just mix some cold water in it, so the temperature becomes normalized. Okay.
Yeah.
So when you mix hot water and cold water, okay, in that case, what is the final temperature of the mixture? These kind of numericals are also there. So here also we are going to do the same thing. Mass, we will take this as M1
Yeah.
and M2. Then we are going to have specific heat capacity. Okay, C1 and C2. Obviously here both the values will be same.
Yeah.
That's 4.2 joules per gram degrees Celsius. Okay, here in temperature, we are going to have three parts. One is initial temperature. Next one is final temperature. And then the difference.
Yeah.
Okay, let us suppose that we are having 20 grams of hot water that is mixed with say 40 grams of cold water. Let us assume that the initial temperature of hot water is 90 degrees Celsius and the initial temperature of cold water is 10 degrees Celsius. We are supposed to find out what is the final temperature of the mixture.
Yeah.
So the sum that is asked to you is 20 grams of water at 90 degrees Celsius is mixed with 40 grams of water at
10 degrees Celsius.
10 degrees Celsius. What is the final temperature of the mixture?
Yeah.
Okay. Obviously, because you are mixing them, final temperature will be same.
Yeah.
Okay. Delta T1 over here, this is going to be 90 minus X.
Yeah.
And delta T2 over here is going to be X minus 10. Correct? Because I'm supposed to take over here the positive difference.
Yeah.
Obviously, when you are mixing water which is at 90 degrees Celsius and 10 degrees Celsius, the temperature is going to be between 90 and 10.
Yeah.
So it will be less than 90
More than
and it has to be more than 10. So that's why the difference is taken this way.
Yeah.
Okay. Then I can obviously use the formula heat lost is equal to heat gained. That is M1 C1 delta T1 is equal to M2 C2 delta T2. Obviously in this case both of them are water on either sides.
Yeah.
So directly you can strike them off. Mass of hot water is 20 grams.
Yeah.
Delta T1 is 90 minus X. M2 that is mass of cold water, that is 40 grams multiplied by delta T2 is,
X minus.
still you can see this is outside the bracket.
That'll be 2, 1. 1
Correct?
Yeah.
We can do direct cancellation over here also so that our calculation becomes simpler.
Yeah.
So this is going to become 90 minus X.
Equals to 2x minus
This is equal to 2x minus
20.
okay.
Yeah.
This X will come here.
Okay, we'll go there. So 1, 1, 0 equals 3x. Yeah.
Okay.
So it is 6.67.
This is the final temperature of the mixture.
Yeah.
Okay. So these kind of numericals will be there.
Should it be like 30 because between 20 and 40?